In this video, we're going to talk about common logarithm. Common logarithm is when you have y equals log base is 10 of x. When you have a base 10, we call that logarithm common logarithm. And when the base is 10, we usually don't write base 10. We just say log of x. It's like when you have let's say y equals x, and you already know that exponent is 1. When the exponent is 1, you don't write 1 there. It's like that. When you have a logarithm that is base 10, we just write it as log of x. So if you don't see a base, you know that there's an invisible 10. So when you have y equals log of x, that is same thing as 10 to the y equals x when you change it to exponential form for when x is greater than 0. Remember, x over here has to be greater than 0, which means it has to be positive. Let's evaluate log of 0.001. And notice there's an invisible base 10. Now before we do that, let's kind of review decimals. If you have 1 over 10, that's the same thing as 0.1. What about 1 over 100? That's the same thing as 0.01. And 1 over 1,000 is 0.001, and so forth. This is a basic math that you need to remember. Now, if you want to evaluate this, again, log is an exponent. So let's put that as y. This whole thing is y. So you get 10 to the y is equal to 0.001. Now, in order to solve for y, you need to have a same base. So let's change it to 10 to the y is equal to, now this thing is the same thing as 1 over 1,000. And 1,000 is the same thing as 10 to the third, isn't it? And 1 over 10 to the third is the same thing as 10 to the negative 3. So in order for this to be equal, y has to equal to negative 3. Therefore, this whole thing is equal to negative 3. Now, what about 10 to the log of 5? This is an exponential form. And remember, this base right here is invisible 10. So let's change the exponential form into logarithmic form. So log base 10 of something. Remember, this we're going to let this whole thing equal to some value y. Log base 10 of y is equal to exponent, which was log of 5. Now, since you don't see the base, there's an invisible 10. Now notice, this is log of base 10, log of base 10. Only when these two are equal to each other is when y is equal to 5. Therefore, this whole thing is equal to 5. And you want to evaluate log of 26. So again, there's invisible base 10. So let's call this y. So you have 10 to the y is equal to 26. Now this one is difficult to do without the calculator because how are you going to change 26 in terms of base 10? So in this one, what you need to do is you just need to use your calculator, log 26, and you'll get approximately 1.42. So this one, you need a calculator. And what if you have a log of negative 5? Again, there's an invisible base 10. And remember, whatever is inside the log here, it has to be positive. But unfortunately, we have a negative. It's a negative 5. So this is undefined. It does not exist. And you might want to double check with your calculator. When you put log of negative 5, you'll get an error. And next, we need to talk about natural logarithm. We talked about common logarithm where the base is 10. When we say natural logarithm, it is a log with base e. And what is e? E is an irrational number that is approximately 2.718281828 and it goes on forever. The popular irrational number that you guys are used to seeing is pi, which is approximately 3.14 and goes on forever. So e is another irrational number that you have to get used to from now on. Now, when we have y equals log of base e of x, instead of writing it like this, we just write it as y equals ln x. So this is a symbol for natural log of x. Again, when you see natural log of x, this is the same thing as log with base e. So when you have y equals log of e to the x, log base e of x, if you want to change it to exponential form, it's going to be e to the y equals x. Again, x has to be positive. So these are inverse. Y equals natural log of x and y equals e to the x. These two are inverse of one another. And since f of x equals natural log of x is inverse of e to the x, what's going to happen is, remember when you have f of f inverse of x is equal to x, and f inverse of f of x is equal to x. They cancel out each other. That's what's going to happen. So if you have natural log of e to the x, natural log and e cancels out, you just get x. And when you get e to the natural log of x, e and natural log cancels out, you get x. So let's evaluate natural log of e 0.73. Well, you know that natural log is log base e of e to the 0.73. So let's call this whole thing y because log is exponent. So it's going to be e base e to the y is equal to whatever is inside here, e to the 0.73. In order for this to be equal to each other, y has to equal to 0.73. This is a long way of doing it. Just think about it. Natural log and e cancels out. So you just end up getting what? 0.73. So shortcut is much easier. What about if you have a natural log of -5? Again, this is undefined y. Whatever's inside here, it has to be greater than 0. Positive, but this is negative. So therefore, this whole thing is undefined. How do you evaluate e to the natural log of 6? This is an exponential form. So let's rewrite it as a logarithmic form. And let's call this whole thing equal to y. So e log base e of y should equal to exponent, which is exponent right here, natural log of 6. Now, what is natural log? It's a log with base e. So you can rewrite it as log base e of 6. These two are equal to each other when y is equal to 6. Therefore, this whole thing is equal to 6. Now, however, remember the shortcut e and natural log, they will cancel out each other because they're inverse. So you just end up getting 6. So again, shortcut is much easier and faster. And let's evaluate natural log of 4. So natural log is log of base e of 4. And remember, we're going to call this y. And log is exponent. So base e, e to the y, is equal to 4. If you change it to exponential form, this is what you get. Now, in order to solve this, you need to change, you need to have a same base. Either change E in terms of base 4 or change 4 in terms of base E. But that is very difficult to do. So what we need to do is we need to use our calculator here. So natural log of 4 is approximately 1.39. So this one you have to use your calculator to evaluate.